All right, let's talk about careers in data analytics. We're going to cut through all the noise and give you a super clear, straightforward roadmap to get you started in this really exciting field. So let's just dive right in.
So, have you ever been scrolling through job postings and just felt completely lost? You see data analyst, data engineer, data scientist, and you're thinking, what is the actual difference here? Well, you are definitely not alone. It's a confusing landscape for sure. But don't you worry, by the end of this, you'll have a crystal clear understanding of who does what. So here's our game plan. First, we'll decode all those different job titles. Then we'll dig into the essential skills and tools you're going to need. After that, we'll trace the entire journey of data from start to finish. We'll demystify what predictive models are all about, and we'll wrap up with the professional mindset that really separates the pros from everyone else.
All right, first up, decoding the data roles. Before you can figure out where you fit in the world of data, you got to understand who all the key players are on the team. Let's start with the two titles you hear about most often. A data analyst is kind of like a historian and a detective. They're focused on the what and why of past data, using tools like SQL and Tableau to find those actionable business insights. A data scientist, on the other hand, is more of a fortune teller. They're focused on what's next. They use powerful languages like Python and machine learning to build models that predict the future. Now this is the whole ecosystem. It's fascinating, right? The business analyst is the translator between the business folks and the tech folks. The data engineer builds the digital highways, the data pipelines that move all the information around. Then your data analyst explores that data for insights, and the data scientist uses it to build those predictive models. And of course, the system analyst makes sure all the underlying tech can actually handle the load. They all have their own lane, but they're all driving in the same direction. Okay, so now that we know who the players are, let's take a look inside their toolkit to see what they're using to get the job done.
On the technical side of things, some skills are just non-negotiable. SQL, the language for talking to databases, is a must-have for pretty much everyone. Python and R are the heavy lifters for analysis and machine learning. You absolutely need a good foundation in math and stats to know what's really going on. And of course, tools like Tableau or Power BI are how you make your findings look good and tell a compelling story.
But listen, being a tech wizard is only half the battle. The absolute best data pros are incredible communicators. They can explain super complex ideas to people who don't live and breathe data. They have strong business acumen, which is just a fancy way of saying they get how the business works and can connect their analysis to the bottom line. So the big takeaway here is, don't just learn to code, learn to translate that code into business value. So let's zoom in on these languages for a second. Python is the jack of all trades, used by just about everyone. R has its roots deep in statistics, so it's a huge favorite for academics and specialized modeling. SQL, like we said, is the absolute bedrock for pulling data. And then you have SAS, which is still a major powerhouse in industries like finance and healthcare, where everything has to be super regulated and by the book.
Moving on to Section 3, the big picture data flow. You know, to really get good at this, you have to understand the entire life of a piece of data, from the second it's created to the moment it helps someone make a big decision.
And this slide shows that journey perfectly. It all starts at the source. Could be an app, a sales system, whatever. Then it gets ingested or pulled into one central spot. That's where the ETL magic happens. Extract, transform, load. The data gets cleaned up, standardized, and basically made useful. It's stored, and then finally, it gets analyzed or used to train models. But it doesn't stop there. That last step is so important, deploying the models and then watching them to make sure they're still doing their job right.
This is the perfect lead into our next section, models, simple but powerful. I know the term machine learning can sound really intimidating, but the truth is, what people use day to day in business is often way more approachable than you think.
Take a look at this number, 80 to 90%. What on earth could this represent in the world of predictive modeling? Any guesses?
It's the percentage of models used in the business world that are based on really simple, proven, and, this is the key, understandable methods. And why is that? Well, because in business, being able to explain why a model made a decision is often just as critical as the decision itself. You have to be able to trust it, and that means clarity almost always wins over complexity.
So, the first big category of modeling is called supervised learning. The best way to think about this is like studying for a test when you already have the answer key. The model learns from a ton of historical data where we already know the right answers. This is perfect for stuff like flagging a credit card transaction as fraud or forecasting how much we'll sell next quarter.
And the other main type is unsupervised learning. Now with this one, there is no answer key.
The model's job is to look at all this messy data and find the hidden patterns all by itself. I love the analogy of being told to organize a huge library of books that have no genre labels on them. It's amazing for things like discovering natural customer groups or spotting weird, anomalous behavior.
So if you're just starting out, where should you put your energy? Honestly, master these two. Logistic regression is the absolute workhorse for any yes or no question you can think of. And K-means clustering is your go-to for finding those hidden groups in your data, which is perfect for things like targeted marketing campaigns.
And that brings us to our last section, and this might just be the most important one of all. It's about the professional's mindset. How to move beyond just writing code and start creating some real, tangible value.
I really love this quote. It just perfectly nails what a career in data is like. You're always going to be learning, you're always going to be looking things up, but you have to have a strong foundation of core knowledge that you can just pull out of your head instantly. That's what lets you connect the dots and have those really creative, insightful conversations.
And here it is. This is the secret weapon, domain knowledge. Understanding the industry you work in, whether it's retail or finance or healthcare, that is your superpower. It's what lets you ask the right questions, spot the patterns that actually matter, and turn a spreadsheet full of numbers into a real strategy that can change the direction of a company. Okay, so what stuff should you really know cold? No Googling allowed. This slide is basically your cheat sheet. If you want to be an analyst, you should never, ever have to look up what a SQL join is. Aspiring data scientist, you need to know the difference between regression and classification in your sleep. This is that core, foundational stuff that builds your credibility and lets you think fast on your feet. So, what's next? Where do you go from here? Well, here's your action plan. Don't just take courses. Build a portfolio of real projects. Get your hands dirty with actual experience, even if it's an internship or freelance gig. Go out and meet people in the field. And when you get to the interview, focus on explaining how your skills are going to solve their business problems.
We've covered the roles, the skills, the whole process, and the mindset you need. You officially have the roadmap to a successful career in data analytics. So the only real question left is, what business problem are you going to solve first?